Today I will discuss about Phi correlation coefficient. Hello, good evening. I am Dr. Nazrul Islam, Associate Professor, Department of Geography, Kuzbihar Panchalan Burma University. Now we have to define Phi coefficient. The Phi coefficient, also known as Phi correlation coefficient, is a measure of association or correlation between two categorical variables. It is a useful measure to determine the strength and direction of association between two categorical variables, especially when dealing with binary data or dichotomous data. The formula for calculating Phi coefficient is given here, where A represents the number of observations both variables are in category 1. B represents the number of observations where the first variable is in category 1 and second variable is in category 2. C represents the number of observations where the first variable is in the category 2 and second variable in category 1. D represents the number of observations where both variables are in category 2. So this formula has been explained here in this table. Suppose we have two variable 1 has the yes and no observations, variable 2 also yes and no observations. Suppose we have put here A, B, C, D, and if we multiply this, cross multiply this A and D, we can get A and AD. If we multiply B and C, we will get BC. Then the total A plus B and C plus D is here, and A plus C and B plus D is here under root. Here note that a positive correlation indeed indicates that when one variable increases or decreases, the other variable also increases or decreases. On the other hand, the of any variable more likely to be true for other variables. However, the notion of the correlation is more commonly associated with continuous or ordinal variables, while association or dependence in terms is used in nominal or categorical variables. Here, for this reason, we have used the term association, because we will use categorical or nominal data. Number 2, the contingency coefficient can be used for measuring association in contingency table of various sizes, not just 3 into 3 or 4 into 4, and this we will discuss later. Again, number 3, Kramer's V is especially used when you have unequal contingency tables with nominal variables, and I will also discuss in my next video. So Phi coefficient ranges -1 to +1 like other correlation coefficient. We have taken an example for discussing about the Phi correlation coefficient. Suppose you have survey data from a group of people and you want to determine if there is an association between gender and preference of tea. Both variables have two categories. Suppose gender category 1 male, category 2 female, and preference of for tea, category 1 likes tea and does not like tea. Now we collected data from 100 individuals and found the following counts. Here A, males who likes tea equal to 35, B, males who don't like tea 15, C, females who likes tea 25, and D, females who don't like 25. So by putting the phi correlation coefficient formula, we will get the result as 0.20412. This is the result. So in this example, the phi coefficient is approximately 0.20412. Since it is a positive and not close to plus 1 or minus 1, it suggests a weak positive association between gender and preference for T. This means that there is a slight tendency for one gender to prefer T more than other, but it is not a strong association. Now we will see whether this correlation coefficient is significant or not. To check the significance of the association between two categorical variables, you can perform Chi-square test of independence. The Chi-square test evaluates whether there is a statistically significant association or dependence between two categorical variables. As we have discussed already, we have four categories of data, and we will take null hypothesis and alternative hypothesis in this case. The null hypothesis is there is no association between gender and preference for T. That means variables are independent. And alternative hypothesis is there is an association between gender and preference for T. That means variables are dependent. So, like other chi-square test, we will discussed here how to determine the chi-square value by using the formula summation r, that means row, multiplied by summation c, that means column, divided by total observation, that means n. So we will get the expected count for likes t and males by using this formula r, summation r1 multiplied by summation c1 divided by n. Here note that here I have used 1 1 1 2 2 1 2 2. This should be cleared. See the table. We have two categorical data, males and females, and likes T, does not like T. Here 1 1 means row 1 column 1. This is the 1 2 row 1 column 2. This is 2 1 means row 2 column 1. This is 2 2 means row 2 column 2. So never be use 11 12 21 22. Rather it should be pronounced as 1 1 1 2 2 1 2 2. For this reason I have written here 1 1 1 2 2 1 2 2. For each categorical variables have expected count, that is 30 for 1 1, 20 for 1 2, for 2 1 it is also 30, and for 2 2 it is 20. So we will use the chi-square formula of, that is summation of by observed count minus expected count square divided by expected count, that means summation o minus e whole square divided by e. So this is the serial number, as I have mentioned, 1 1 1 2 2 1 2 2. So observed count, we have this given data and we will determine this expected count. This is o minus e, that is difference between observed and expected count. This is the square value, and after that we will chi-square here o minus e whole square divided by e. We will get this value 0.833 1.25 0.833 1.25, and the summation value is 4.1667. Therefore, the chi-square statistic is approximately 4.167. This is the chi-square value. So we have to take degrees of freedom in chi-square distribution. This is a 2 into 2 contingency table. So degrees of freedom is determined rho minus 1 multiplied by columns minus 1, that is r minus 1 into c minus 1. We have 1 degrees of freedom, and we have taken alpha as 0.05, that is level of significance, and the critical value or tabulated value is approximately 3.841. Now we have to comment on the result. As I have mentioned that chi-square statistic is approximately 4.1667. The critical value is 3.8415, and by using Python we determine p-value which is approximately 0.0412. Thus, the chi-square statistic 4.1667 is greater than the critical value 3.8415 at the 0.05 significance level. This means that we reject the null hypothesis. Further, the p-value 0.0412 is less than the significance level alpha, that is 0.05, providing additional evidence to reject the null hypothesis. Therefore, based on the phi coefficient, chi-square statistic and p-value, we have sufficient evidence to conclude that there is an association between gender and preference for T. In other words, the variables are dependent and there is a statistically significant relationship between gender and preference for T. Now, this is the phi coefficient and chi-square code that has been performed in Python, and if you want to copy this code and paste in PyCharm, you will get the result as I have mentioned in my previous slides. And this is the phi coefficient, we know this. This is the chi-square value, this is the p value, this is the critical value, and the comment is reject the null hypothesis. So you can try this phi coefficient and chi-square in Python software. Thank you. Marcy Bikov.